Hello everybody. Today we're doing another example of curve sketching. This time we're looking at a function that's going to have some asymptotes. Here I'm given some information about the value of the function, values of its first derivative and second derivative. I want to use that information and try and come up with a qualitative sketch of what the graph of this function might look like. As usual, I'm going to start with what I know about the function itself. For instance, I'm told that f of 0 is 3. So when x is 0, y is 3. That's just a point I can plot on the graph right there. Next, let's make some notes about this limit information. As x gets more and more negative, f of x gets closer and closer to -2. That's a horizontal asymptote that's being described to us there. So when x goes this way, the graph gets closer and closer to y equals -2. Horizontal asymptote over here. Similarly, when x goes to positive infinity, f of x gets closer and closer to 0. So on the right, I have a horizontal asymptote that coincides with the x-axis. Okay, so I've done this, this, and this. At x equals +2, I'm seeing a vertical asymptote. Remember, a vertical asymptote is going to be an x value such that one of the one-sided limits is positive infinity or negative infinity. I can say a tiny bit more than just that vertical asymptote. As x goes to 2 from the left, I go towards negative infinity. I'm going to denote that with this downward arrow to remind myself that the graph is going towards that asymptote going down on the left. Similarly, on the right, as x approaches 2 from the positive direction, the function's getting larger and larger without bound. So I'm going to draw a little upward arrow right there to remind myself of that. Okay, so I have a little bit of information about where the function comes from, where it's going, and a tiny little bit about what it does in between. Now let's use the first derivative. F prime is positive on negative infinity to 0, so over here. Positive first derivative, increasing function. Let's make a note of that. Similarly, from 0 to 2 and 2 to infinity, it's going to be decreasing. Notice that it doesn't say 0 to infinity. That's allowing for the possibility that x equals 2 is not in the domain of the function. And in fact, that's the way I'm going to end up sketching this. Next, we're looking at second derivative information. F double prime positive from negative infinity to -2, and from 2 to infinity. Positive second derivative, graph that's concave up. And then finally, the graph is going to be concave down from -2 to +2. Okay, so I've taken care of my vertical asymptote, my first derivative, and my second derivative now. Okay, once I know where a function is increasing, decreasing, concave up, and concave down, I can use my general knowledge about what functions look like when they have those properties. A function that's increasing and concave up, as this function is when x is less than -2, is going to look like this. And then from -2 to 0, the function is going to be increasing and concave down. So that means it's going to look like this. Then from 0 to 2, decreasing and concave down, and from 2 to infinity, decreasing and concave up. Now, the way I remember these general shapes is by thinking about the unit circle. Each quadrant of the unit circle is going to have one of the 4 combinations of increasing, decreasing, concave up, and concave down. Now, all I have to do is to take these pieces, put them up here so that they go through the proper points and meet the asymptotes in the proper way. So I want to start at this horizontal asymptote of y equals -2 with a graph that has generally this shape until x equals +2. So like this. And then at x equals -2, I think I said +2 a moment ago, I mean -2, the graph becomes increasing but concave down until it reaches this point at 0, 3. So like this. Try and neaten that up just a tiny little bit. And then at x equals 0, the graph becomes decreasing and concave down. And it will remain that way until this vertical asymptote. Notice the local maximum at x equals 0. That's where the graph goes from increasing to decreasing. So by the first derivative test, there should be a local maximum there. Finally, at the right end, the graph is going to be decreasing, concave up between 2 and positive infinity. So it's going to look like this. Okay. Overall, this must be the general shape of any function that has these properties. Of course, the specific points that this graph passes through might change with the exception of this one, but this has to be the overall.